When I first read that wild lupine, after flowering and creating its seeds, goes into a period of senescence and does not regrow until the following year, I wondered why. Why would nature create a perennial that would not use the entire growing season? Was it genetic, or might there be some other reason? This picture, taken on June 4th, 2017, shows two wild lupine plants that were started in 2016 in a soil that had been amended to increase its ability to produce protein. Yet again, here are the same two plants on July 23rd, 2017. Both the plants have finished flowering and have created their seed pods, which as they turn dark are becoming mature, and you can see on both plants the end of the leaflets are starting to die back. Here on August 13 is one of the plants where you can see the original leaves. Some of them are visible, still dying back from the tips. But what's new are some new leaves that have appeared that are the light green or yellowy green leaves that have a pattern in the leaflets that you don't normally see. In this picture on September 3rd, you can see new leaves appearing that are now a darker green without so much pattern visible in the leaves. This picture, taken October 21st, is my final picture for the year. This plant, which flowered, created seeds, and dispersed the seeds, has continued to grow new leaves throughout the season. The leaves are certainly not as dark as the leaves it had in the spring, but nevertheless, it has continued to grow through the season, and it has not gone into senescence. The 5 wild lupine in this picture are all first-year plants. In the next series of pictures, I follow their growth through the 2018 season. On the left side of this picture, the 5 lupine plants, now are in their second year, are starting to flower. This picture, taken June 10th, illustrates the differing growth rates among the 5 plants. The plant on the right has not yet flowered, while the plant on the left has not only created its flowers, but it's created the pods holding the seeds. This picture, taken June 23rd, shows the plant on the left finally flowering with 2 inflorescences, while the plant on the right, which had 18 inflorescences, has created its seed pods, and the plant is dying back severely. This picture, taken July 14th, shows the plant with the 18 inflorescences showing some regrowth in the lightly colored green leaves. Later in the season, however, this regrowth also died back, and the plant did not come back in 2019. At the end of July, the plant on the left, which originally had 18 inflorescences, has had virtually all of its leaves die back. The plant on the right end, however, is now exhibiting a 3rd inflorescence after the first 2 have finished flowering and started setting their seeds. The plant in the picture was the one that had its first flowers after the other 4 plants. Here on August 3rd, the pods on the first 2 inflorescences are distributing their seeds. Its 3rd inflorescence, shown in this picture, does not appear to be any weaker than the first 2. Some of the new leaves, however, are the lighter colored leaves that showed up on other plants after they created their seed pods. There does not appear to be any dieback of the original leaves. This plant is the same plant that was pictured on October 21st, 2017 in this video. Again, in 2018, the plant has had a substantial growth of new leaves after the original leaves died back. The leaves again are the lighter colored green or the yellowish green, but in neither case, either in 2017 or 2018, has the plant gone into senescence. A possible explanation for the dieback of the wild lupin leaves comes from Volume 1 of the Albrecht Papers, Chapter 23, titled Droughts, the Soil as Reasons for Them. Corn is fired in a drought when the lower leaves turn yellow. Albrecht explains what process is taking place when corn is fired in a drought. The problem for the plant is that the shallow surface layer of the soil containing nutrients required by the plant has dried out. Any person who has houseplants knows that a plant needs water when it has wilted. When corn is fired but not wilted, the lack of nutrition is the problem. Roots going deeper into the soil are able to get water from the infertile subsoil. In order to maintain the upper, younger, and growing leaves of the plant translocates nutrients, especially nitrogen, from the older, lower leaves, causing them to fire. When wild lupin flowers and then creates its seeds, it requires sufficient nutrients, especially nitrogen. Depending on the size of the plant, the quantity of the seeds being created, and perhaps the age of the plant, it may be necessary for heavier seed loads relative to the size of the plant to require the plant to translocate nutrients from its leaves to seed production. As illustrated in the previous examples, plants with a light load of seeds may not experience any dieback of the leaves. Plants with heavier loads of seeds may have different degrees of dieback in their original leaves. After completing the seed creation process, however, these plants resume creating new leaves. These new leaves, usually in a lighter green or yellow-green color, suggest the availability of nutrients to support this growth is lower than it was for the darker green leaves being created in the spring. Going into the fall, the new leaves being created may be a darker green than those first produced after the seed creation process. Light green leaves in the spring and white flowers or other light-colored flowers may be indicative of insufficient soil fertility to properly nourish the wild lupin. If the plant is not properly nourished, how can it properly nourish a butterfly caterpillar?